Let me get to the page real quick.
What?
Let me get to the page real quick.
Okay. I need to open mine too.
How you doing?
What?
How you doing?
Pretty good.
Busy day?
I've just been kind of chilling, working on homework. Haven't really done much other than that. I went back and I was like watching the videos that she made with Aldo.
Yeah.
Oh, we didn't do lesson 14 homework yet. Okay. Please review for exam in online textbook. So did you start going back and learning everything over again?
Yeah. I'm at lesson. Wait, give me a second. I'm at 12.
Okay.
I'm at 12. So I was gonna do the rest tomorrow and then some on Saturday.
Okay.
Have you?
Yeah, I'm up to I just need to learn 14. I learned everything else.
14.
13 and 14 are pretty easy. It's pretty much the same
Yeah.
thing.
That's what I was thinking. 13 and 14 are like.
Well, and everything is pretty easy in like SPSS and stuff. So
Yeah.
did you open it yet?
Sorry.
Okay.
It's the review for test 2, right? Yeah. Exam 2.
Mm-hmm.
All right. Oh, dang it. Okay. I'm ready, Freddie.
Okay. All right. Did you open it yet?
Yep.
Okay. So for number 2, I think it's the first one.
Given a 90% confidence interval of 45 and a 5 for mean heart rate, which the following is the best representation of this confidence level. You never say chance, I know that. And so these two are out. But yeah, I remember you said confident. We're 90% confident that the true mean. Yeah, so we are.
Okay.
Okay. Number 3. Do you need to?
Oh, okay. That's the distribution.
Okay. So, determine whether the reaction time seconds.
I think it's the third one. No, the distribution is not of each sample is not normal since the sample size is not large enough for either of them.
No, because no, it can't. It can't be. So the researcher decided to construct the confidence and determine the difference of the means is significant. Determine whether the confidence would be reliable. They create QQ plots of both random samples and see that they're approximately normal. Um, well, they're normal, so it's yes for sure.
Well, um, Okay. But so because doesn't it have to be both of those together or either or?
What do you mean?
Like so for the what does it say? The confidence level constructing a confidence interval satisfied doesn't have to be more than 30 and then it has to
No, no, because it's 20 females and 15 males.
but isn't it aren't there going to be two different means for this one?
Um,
Because it's seeing like how it differed from that of females. So it's like there's 20 females and 15 males.
oh, but I don't think it matters so because like it says it's normal. It says um what is it? It says determine whether the confidence would be reliable, blah blah. See that they are approximately normal. Wait. Determine whether the confidence. Yeah. So like so the data is normal. So it's normal. So oh, are you saying that because the sample is less than 30 for each side that like it's not normal?
Yeah, exactly.
But it says it's normal though. Like it says it's itself. It says and they see that they're approximately normal.
But I think it has to have both. I think it has to be approximate, like the distribution has to be normal, and then it also has to be more than 30.
I don't think so. I don't think so.
Oh, you're right. No, you're right. Sorry.
I don't think it has to be more than 30. I think that was for
That's
like
normal.
the ski the it was isn't it's not for like the QQ plots. It's for like the other it's like the one before that.
Well, and so here are the requirements. Number one is it has to be a simple random sample,
Yeah.
which it is, right?
Yeah.
And then it has to be either normally distributed or have more than 30 people. So,
Yeah, but the total is this 35. But I think it's just I don't know. I think it's normal. I think it's yes.
so is it the first one or the second one?
Its data is normal. So like yes, the distribution and the mean of each sample is normal since the data have been determined to be normal. Because it says it's normal. It says and they see it they're approximately normal.
Mm-hmm. So the first answer says yes, the distribution of the mean for each sample is normal. So I think it if
Yeah,
it didn't
but it doesn't even talk about the central limit theorem. Like this has nothing to do with the central limit theorem.
oh no, I know it's number two. I'm just like pointing out like it says for each sample.
Yeah.
So like I think if it wasn't normally distributed and each sample had more than 30, then it
Yeah.
would be okay.
Yeah.
Because I don't think the two numbers combined counts. I don't know though.
Okay.
Anyway, we can move on. The four types of confidence intervals listed below, which one is appropriate for the experiment? Um,
Which is appropriate for the experiment. It'd be it'd be the confidence interval for the difference of means.
using
Because
independent.
they're independent. Yeah, the sample is independent, so using independent samples.
Okay, that makes sense.
We should essentially estimating the savings account balance of customers at a large bank. So to make a smaller margin of error, they just need to increase the sample size.
So a balance of 90 bank customers rather than 30.
Yeah. Okay.
Okay. A factor makes propeller.
So it's effectively makes propeller drive shaft for ships to the qualities.
Sample mean is 1,000.
Calculate the 95% confidence interval for the true mean of the. So we need that formula for this one.
Which formula is that?
It's in one of the lessons. I remember.
Oh, wait. Got it right here.
You do?
Okay, so it is the sample mean plus. Oh, what's S? This is the formula right here.
Oh, yeah, right there. So sample mean plus the t-score. Did you say is that the t-score?
Yeah, it's the.
I don't think so. I think it goes back one. That's the one that's.
Oh, I'm on the. You're right.
It's on the wrong formula. This one that's like it's like way in the beginning. I remember.
Yeah, because that's the when sigma's unknown. So I have it here somewhere. I made really good notes.
All right.
It's like. What the heck? I thought I had really good notes. What that other formula? It's the. Yeah, because like it's not the T. Oh, it's like the Z star. That's what. Oh, right here. Okay. So it's X, or sorry, the population mean minus the Z. Oh, so this is the lower bound. So 1,000, right? And then so the Z, what do they call that score? The Z special symbol thing.
Which one are you talking about?
Well, so this is the formula that I forgot.
Okay, so it's the so sample mean minus the z-score.
So yeah, it's not z-score though. It's like z special something. He said. It's like you use they give you three numbers like. For 90%, it's.
Oh yeah. It gives you three numbers for each of the intervals.
Yeah, so this is a 95% one, right? So the number is 1.96. How many? Wait. But we don't have a sample size.
We don't.
We have the standard deviation.
Let's see.
Maybe we don't need the sample size for this one.
So so you have 30 customers. Wait, no, that's not the right question. So it gives you the sample mean. It gives you the sample size is 4.
4?
Yeah.
Oh, 4 drive shafts. Oh, yeah. I see. Okay.
So 4 sample size gives you the sample mean, and it gives you the confidence interval of 95%, and it gives standard deviation of 2 millimeters.
Okay, so it's the first one then.
998.040.
Mm-hmm. Is that what you have?
Yeah. So I have two.
Yeah, because 998 and then 1,000. Okay, cool.
Awesome. So to assess the accuracy of a laboratory scale, a standard weight that is known to weigh 1 gram is repeatedly weighed a total of n times, and the mean of the weighing is computed. Suppose the scale reading anomaly distributed with unknown mean, population, and standard deviation. 0.01 gram. How much? So we have to find the sample size, which is also another formula that's in the reading. I should have written all the formulas down.
Oh, it's right here. So n equals that level of confidence score times the standard deviation over the margin of error. Does it give us that?
Yeah, the margin of error is plus minus 0.0001.
Okay, so we're gonna want to do
So
1.96 times 0.01 divided by 0.001. 38416.
Yep, 38416. So I got 38416.
Okay. The mean area of the what? Of the several thousand apartments in the new development is 12. It's gonna be the first one.
The appropriate known hypothesis, alternative hypothesis for population mean are for sure knows yeah it's less than.
So it's the first one, right?
Yeah. So sample means less than, population means less than 1250. So yep, first one. In a stats test of hypotheses, we say the data is statistically significant at the level of significance.
You're not Brent.
Hey, if
Wasn't there here?
The p-value is larger.
Are you going to the gym?
Yeah, in a little bit. I'm doing a group test.
You're not.
No, it's not a group test. What do you call it? A group meeting thing. Hey, say hi.
Hello. Who's that?
Hi.
This is Sam.
Hello, Sam.
Hi. How's it going?
You can turn it back around.
Hey, say hi to
Where's
Cece.
Brent?
Cece, say hi.
Hello.
Hello.
Excuse me, James. Would you answer the question?
Brent is doing a secondary. Oh wow, okay, that's.
Do you know this person?
Yeah.
Or have you met before? Have you met in
We're
person, or
like super tight.
you're like pen pals?
We're like pen pals.
Pen pals.
Yo.
What do you mean, ew? What? Pen pals.
What are you doing?
It's a group meeting thing for my stats class. What?
This isn't a group. This is a double date. Or not
No, a double date. This is totally a double date.
Not double date. I didn't mean to
Hey
say
Sam, do you hear that? We're on a
Yeah.
date.
We're on a date, a super fun math date.
Yeah.
Well,
What?
yeah,
Cece.
you weren't entertaining enough.
Okay, I'm sorry, okay, guys. You know what?
We'll just do you.
Oh, all right. Sorry.
No, you're good. The data for each apartment building are bell-shaped with no legends. Can they use an ANOVA hypothesis test to answer that question? Oof, I don't know what that is.
Wait, you already know. Wait, did you already get number 9?
Yeah, it's the p-value is larger than theta or sigma. Is that sigma or theta? What is that?
That's not theta. That's sigma.
That's sigma. Okay.
Because theta is the O with the thing up top.
Oh, that's right. Okay. What's an ANOVA hypothesis? I
Wait,
forgot.
but how do you know it? Give me. I don't. How do you know? How do you know p theta is larger than?
So when you do all your tests, oh crap.
Wait. What did you? So what answer did you get?
If the p-value, okay, so here's what I have written down. If the p-value is less than
Sigma.
I have a fish drone. That's supposed to be I drew it backwards. Oops. If it's less than theta or sigma, I mean, this or the significance level, we reject the null. So in a statistical test of hypothesis, we say the data are statistically significant at the level of significance if the p-value is larger than sigma theta. Oh, that's theta or sigma. Is that not the answer that you got?
Well, I'm looking at this and like, I'm looking at this and it's reading. Wait, give me a second. I have to read. Maybe I'm just reading it wrong.
Okay. That doesn't make any sense. That's just like really, maybe it's just because of the way it's worded.
Wait, where did you read that? 'Cause I feel like it's not.
Pretty much in all the chapters, like we say the data are statistically significant at the level of significance. Oh no, I'm sorry. Okay, so the lower the p-value, the better.
So it'd be less than, right? So it'd be the p-value less
This is
than.
what I read on Wikipedia. This sounds like it sounds pretty close to what it sounds better. It says, but if the p-value is less than the significance level, then an investigator may conclude that the observed effect actually reflects the characteristics of the population rather than just the sampling error.
Which is correct, which means it is statistically significant, right?
So we want the p-value to be low.
Less than. Okay.
Yeah.
That sounds better because I was like,
Okay. No, that's my fault.
A group of statistics students wants to determine if students in the department.
Oh, this is the ANOVA thing. I don't know what the ANOVA is.
The Nova one, okay.
ANOVA is a test for equality of. Oh, this is lesson 14. I haven't gotten to lesson 14 yet.
Yeah. So analysis of variance, Nova.
Let me go to the bathroom.
La la la. La 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 la. So the question is, the data for each apartment buildings are bell-shaped with no outliers. The sample variance are nearly equal. We include that the means are not all equal. If the means do not differ by much, then we do not reject the hypothesis. Use level of significance. Requirements. The data normally distributed in each group. The variances are equal for each group. So then it's fine because the sample of variance are equal. Yeah. So it's
Have you been talking to me this whole time?
no, so I was talking to myself now.
Oh.
Yes, I was reading the lesson 14 and the answer is yes, it is enough that the apartment's building is a bell shape with no outliers because the sample variances are nearly equal.
Okay.
Yeah. Researchers working on new treatment.
Average survival time after diagnosis is the same for the new treatment and the standard treatment. In an early trial, she tries the new treatment on 275
What's up?
Are we actually going to Wyoming this weekend?
Yeah, we're going tomorrow. Oh, not tomorrow, Saturday. But I thought you're not going because of your friend.
No, my friends are coming, but I don't get them to 2.
Okay, then we'll wait till 2. But yeah, make sure you're packed and everything. Like, get ready to leave by 2, though. We're gonna go hike. We're gonna go to. Have you been there, Jackson Hole? It's like a neat little town with like shops and like just like cool town. So we're just gonna go walk around. What's up?
We're gonna hike in the snow.
Yeah. You don't want to hike in the snow? We can just go to the town and just shop and eat and chill. Like, cause if we leave at 2-ish, we'll get there at about 4, and then we can just eat dinner, like walk around a little bit, eat dinner, and then go to the hockey game. Yeah. Oh, we can stay. If you guys want, we can just stay there. In Wyoming, in Jackson Hole. I've got a couple of friends there, but I mean, there's a lot of us though, so we might not want to stay. I don't know. We'll decide to talk to them if they want to stay or not. Okay, thank you. All right. So, sorry, that was CC.
Oh, you're good. So I think it's one of the errors, right?
So, yeah, it's one of the. But let me see. That's what I was thinking. I was looking at type 1 and type 2.
So it says a type 1 error is committed when we reject a null hypothesis that is in reality true.
Yeah, it's type 1 because it says consequently she rejects a null hypothesis. Yeah, so she committed a type 1 error.
Okay, so the type 1 is you reject the null, and the type 2 is you don't reject it even if it's not true. That makes sense. Okay. So committed a type 1 error?
Yeah. Are you eating? What are you eating?
Smarties?
Oh man. Have you had dinner yet?
No. I eat these as I didn't even work out today, but I eat them as a post-workout.
Oh, okay. I haven't worked out today either. I have to go work out after this.
Do it.
I will. Okay, so level of significance. Sigma is made very small, thereby the probability of committing a type 1 error very small. What happens to the probability of committing a type 2 error? What happens to the probability? So obviously, if type 1 error is reduced, right? Yeah, if type 1 error is reduced because the level of sig is very small, then type 2 error obviously enlarged because it's like the opposite.
Okay, so the last one, by reducing the probability of committing type 1, we increase the probability?
Yeah.
Okay.
Nicotine content in cigarettes or cigarettes. That was a good 1.5 measurements on a random sample. 1.53. Is this evidence that the mean nicotine content is actually higher than the advertised? To answer this, test the hypothesis. No hypothesis. 1.5. It's greater than 1.5. At 5% level of significance, you conclude that you should. Well, since the.
I would reject the null.
Yeah, I would reject the no too.
Just because it's 1.53.
And it's 1 point. It says 1.5. Okay. Reject the null hypothesis. All right. You would like to look at the mean number of hours worked for wages per week by male students and female students. You would like a random sample of 100 for each group and test if those means are different. What is the correct statistical procedure? Let's see.
Oh, they had some of these questions on another one. I did not like them.
I know, I hate them.
You would like to look at the mean number of hours worked for wages per week by male students and female students. So it's not a z-test.
No, it's definitely a t-test. It's not one sample t-test.
It's not ANOVA though, right? Because
no,
don't you have to have more than 2?
Yeah. So I'm pretty sure it's independent sample t-test. Because it's just like that last question. It's just like that earlier question. So it's like because it's an independent sample.
Yeah, because like in the homework there's like a example where it's like the husband and the wife. Mm-hmm. So they're like that they're dependent on each other, but like these male students, female students, they're not.
No, they're not.
Okay. And educators interested in academic achievement by males and females. She decides to use only brother-sister pairs when they are next to each other in some order. Should she use a hypothesis? Okay, so it's definitely not independent.
It's dependent, yeah.
I think, is it the very last one? If you select a brother so as to compare his academic achievement to his sister, you must also include his sister.
Of course, yeah, because they're dependent that way. Yeah, I think that's it.
A soil scientist. Ooh, that sounds like a good job.
Soil scientist.
From a field and measured the dissolved organic carbon levels. Then for the mean dissolved. Open the data file dissolved. Okay.
We have to open that dissolved organic carbon data file. Lame.
You guys going to Jackson tomorrow?
Saturday.
Wait.
Oh wait.
We'll talk later.
Yeah.
I thought tomorrow's Friday though. Didn't you just say tomorrow?
No, she didn't. Oh yeah, she said tomorrow, but I think she means Saturday. Just for like the evening. For like a hockey game.
Oh, cool. What was the data called?
Well, yeah. Actually, I was gonna ask the same question. It's called dissolved organic carbon.
Okay, I got my SPSS to work.
What happened?
Dude, it was. Do you have a Mac?
Yep.
So I would click, like I'd open it and it would just bounce. Just like.
Oh, it just keeps bouncing?
It just keeps bouncing and bouncing and bouncing. And like, I was getting so frustrated. And I just restarted my computer a couple times. And then the only thing now is I can't like open them like straight from my downloads thing. I need to have SPS open and then hit the little open file thing.
Oh, interesting. Yeah, I have it open.
Dissolved.
Of the 4 types of confidence intervals listed below, which one is appropriate for this situation?
So we need to do Is it descriptive statistics or compare means? Okay, so it's a 95% confidence interval?
Yep.
Oh, this is a weird question. So the 95% confidence is 11.168 and then 15.217. Is that what you got?
Sorry, I was reading something. What was that?
I skipped to 17 because I have the answer, I think.
Oh, is it 11.168?
Yeah.
Yeah, that one.
Okay.
But for this one, I'm figuring out. So I'm pretty sure it's confidence level for population mean when standard deviation is unknown.
What?
For number 16.
Uh-huh. Is it the second one?
It says which one's appropriate for the situation. I think it's the confidence interval for population mean when standard deviation is unknown.
Yeah, that makes sense because we don't know the they didn't give us the standard.
The theta, yeah.
Okay. Open the data file.
Open the file used Hammers, LA, and New York. Keep opening files. I don't want to open more files.
What was it called?
It's called Used Hummers, LA and New York.
Oh, holy crap. Okay. Hummers for sale in. Okay, I think I just did this one today. You have to like make another variable. So it's Los Angeles versus. Wait. We want to know if there's a difference between Hummers in LA. Okay. You want me to share my screen? Do you know how to do this one?
Wait.
I watched her do it on the homework video just because we got that one wrong.
Wait, I'm still trying to figure it out. Used Hummers. Yeah. The 4 types.
Jacob, what's up? In your life director document, did you want to ask him something? This isn't a real quick. He just wants to know if you want to play it well.
Okay.
So, Aaron has all of your homework, so he's not going to be on. I'm on my computer playing my old friend.
So we don't know.
All right, then, Jacob.
Is it confidence interval for the mean of differences using dependent samples? Or independent samples?
Well, they're independent. They're definitely independent. So if anything, it'd be confidence interval for the difference of means using independent samples. Yeah, I'm pretty sure it's that one. Confidence interval for the difference of means using independent samples. All right. We just have to find the difference of the mean and then.
Okay, so let's see. Okay. Okay, where'd it go? Okay. I don't remember what she did. Oh, definitely not that one. It's not a one independent, yeah, independent samples. So it's just talking about the prices, right?
Yeah.
Price equal. Okay, so it's. Are you? Can you see my screen?
Yeah.
Actually, I want to understand that. So the Los Angeles between Hummers for sale and Hummers for New York is not taking. Is it taking group 1 or group 2? So is it? There's 2 answers. I don't understand why. Equal variance is assumed. Equal variance is not assumed. I don't know which answer it should be.
Which one are you talking about?
So if you look at my screen,
Yeah.
so see how over here there's two lowers and 2 uppers.
Yeah.
Well, if you come over here, the top 2 are equal variance is assumed, and the bottom says equal variance is not assumed.
Yep.
So I don't know which upper lower it is.
I think it's. Wait, what? What number are we on right now? Are you on 17?
No. We already did 17.
Oh no, sorry, never mind. I'm sorry, we're on 19. My bad, we're on 19. Okay.
Well, we did 19.
I think it would be. I feel like it's no, it would be because it doesn't say, it doesn't tell us. Sorry, it doesn't say if the variances are equal, so it'd be equal variance and it's not assumed.
Oh, does it say that on there?
No, like I would assume because it would tell us if it's assumed if the variances are equal.
Oh, so it says the true difference of mean. So it's the bottom one, you think? The negative 423?
Yeah. Because it would say if it's assumed to be equal.
Oh, so I did that backwards. So do you want me to show you what I did for this one real quick?
Yeah.
So this is it, right? This is the thing that has the price on it.
Yep.
So I'll just kind of follow what she did in the video. So it's asking what's the difference between the ones in LA and the ones in New York.
Yeah.
So what you do is you come over here in a new variable place,
Yeah.
and you put, instead of it being Los Angeles, you give Los Angeles a number, and then you give New York a number. So then it's group 1 from New York, and then group 2 is from LA. But I switched it on accident. So LA is actually supposed to be 1.
Okay.
And then, so then you come up to here, and then independent samples test, and then you put the test variable over here for price, and then you come down here, the group variable. This is the 1s and the 2s that equal New York and LA.
Yeah.
And then you just define the groups. Group 1 would be LA, and then group 2.
Okay.
Does that make sense?
Yeah.
And then you just hit OK, and then it gives you what we just found.
Cool.
And then we decided it's the one on the bottom, right?
Yeah. Okay. Okay, number 20.
Okay, we're almost done.
Yeah.
Okay.
Bone density.
Bone density.
Yeah, it says, isn't it? Open the data file. Oh, exercise bone density. Exercise bone density.
Ooh, so this one is going to be is this an ANOVA one?
Yes, ANOVA.
So I did not look up how to do this. So let's see.
Yeah, because it compares 1 and 2. Calculate the test of the stats.
Excel SPSS instructions. Analyze, compare means, one-way ANOVA. The dependent list. Descriptive means plot. Continue. Oh, I think we have to group each one of those.
Separately?
Yeah. I don't know, because... Oh, yeah, we do. So if we make the control group 1, oops, let's made that one 11, and that one too. Okay. One-way ANOVA. And then the group factor is that. Options, descriptive means plot. Okay. So what's it asking? What is the correct? Oh, so obviously ANOVA, right?
Yep, and it's Nova for sure.
Okay. So calculate the test statistic, which
The
is
test outs. So it'd be that on your screen right there. It'd be F, yeah. So it'd be 7.978,
okay.
which would be C. And the p-value,
Is this one?
yeah, it's a significant. So it's 0.002.
Okay.
Okay.
So let's remember how to do that. Like, just remember how to do this when you take your test,
Yeah.
because it's probably going to be pretty similar, I think.
Yeah. Wait, so go back. How'd you get to the screen again? What did you put it?
For this one?
Yeah.
Okay, I'll just hold on. So this is the bone density.
Yeah.
And then here's I just made another column because you got to put each one in different groups. So the control group is 1, low jump is 2, high jump is 3. Analyze, compare means one-way ANOVA.
Yep.
These will come up over here, dependent list, wrap bone density, and then this is where you put the groups.
Yep.
And then it just said on the instructions you need to go to statistics and hit descriptive and then means plot.
Yep.
Continue, okay.
Okay, sweet. Thank you.
Yeah.
All right.
Which of the following best expresses the conclusion of this test? So our p-value is well below the level. So this is where you have to go back and read. Researchers like to determine the mean.
Which of the following conclusions? There's sufficient evidence to include that the bone density of all three groups is about the same. That's not true. There's sufficient evidence to include that the bone density of at least one of the groups is different than the bone density from at least one of the other groups. That sounds right. There's insufficient evidence to conclude that the bone density of all three groups is about the same. No.
So the bone density, it did go up. So
Yeah, so I think it's B.
okay. So when she was going over this in like the video, she just said like to go back and read what they don't really give you like a real hypothesis, so that's what I don't like.
Yeah.
So researchers would like to determine blah blah blah. So that doesn't make sense to me. Okay, so yeah.
Oh man.
Okay, this last one, and then we're done.
Was it the last one?
Yeah. What's the file called? Direct flight costs.
Direct flight costs.
Okay, so we're gonna want to do not a z-test, not a one sample t-test, not ANOVA. It's gonna be
It'd be dependent. It'd be a dependent samples test.
Is it?
Yeah. Pretty sure.
Okay. I need to make. Okay, so analyze, compare means, independent samples test. So is it going to be 90 minus 14 or the 14 minus 90?
Which one? What are you talking about?
So-
Oh, the 90 days or 14 days one.
Yeah, so we're looking at the difference between the two. So I think it's the,
Try 90 minus 14.
oh, wait. Is this right?
Hey yo.
Oh, so it's dependent. I was on the wrong one. So
Yeah.
paired samples t-test?
It's dependent samples test. Okay, so test stats.
Is it 1.685?
Yeah, it's T. Yeah, that's the test stats. So 1.685. Is that one of the? Yeah, it's A.
What did I do though? I used the. Okay, and then the sig.
Right here, it's the sig's the p-value, so 0.096.
So is it supposed to be two-tailed though?
Yes.
Oh, because we're just looking for a difference on either side, so that's
Yeah.
fine.
Last one. Which of the following best expresses the conclusion of this test? Use a sig level of sig of 0.10, so 10%. There is sufficient evidence to conclude that there is no difference in the cost of tickets. That's not true. There is significant evidence to conclude that there is a difference in the cost. That's true. There is insufficient evidence to include that there's. Okay, yeah, it's sufficient. It's B.
Because the level of significance is it's 0.096, so that's less than 0.1.
Yeah.
So it's sufficient evidence.
Yes, there's sufficient evidence.
Okay, cool. Shall we submit it?
Yeah, I'll submit it right now. Most of these can kind of be figured out through logic too, though. Like,
Yeah. Well, and it's nice you have why is there a homework? Okay.
Sweet. We got all of it right.
Nice.
Nice.
Okay, I'm just gonna where'd that go? Stop sharing the screen.